to go on with the talk. So,
Thank you.
Ishan, I think everything is set up for you. So yeah.
Sure. Thank you. And thank you for joining a crash course in Core Web Vitals with some special adaptations for React developers. I am Ishan Anand, and you can reach me on Twitter at IANAND. And what we're going to cover today is what Core Web Vitals are and why they matter. Then we'll spend a bunch of time actually talking about the Core Web Vitals improvement process, because Core Web Vitals is probably unlike any other performance optimization you've probably attempted, and we should talk about why that's different and the best way to go about it. And then we'll do kind of a lightning round going through the 3 metrics in Core Web Vitals and the different optimization techniques that folks on our platform have found to be the most impactful. I am VP of Product at Layer Zero. We are a division of Limelight Networks. And our jam is really bringing the benefits of Jamstack to large, complex sites, household names like these guys, Shoe Carnival and Sharper Image. Folks that have sites that have tens of thousands, hundreds of thousands, sometimes millions of pages. But they want that Jamstack-like speed and Jamstack-like great workflow in terms of developer workflow and developer productivity. But their sites are too big for kind of a static technique. So that's what they get on our platform. And they're using, frameworks that you all know and love, like React or Next.js, which is a server-side rendered version of React. But we also support Vue and Nuxt and Angular. And we have a lot of emphasis on e-commerce. So frameworks like Vue Storefront and React Storefront, or other ones like SAP Spartacus. You can find myself and my colleagues around the web in various places. We run a newsletter on Core Web Vitals. We are core contributors to React Storefront. It's an open source Next.js based e-commerce framework. Myself and our VP of engineering host a podcast called JavaScript Jam, all about full stack development. And in fact, we had 2 folks from the Chrome team recently talking about Core Web Vitals. So I encourage you to go there and check out that episode. And then we run an open mic night or open mic day every Thursdays at lunchtime in the Pacific time zone. Just fire up Clubhouse and look for JavaScript Thursdays. Anything JavaScript or web development is on topic. So find us there. And then lastly, we're hiring. So I encourage you to check out layerzero.co/jobs or limelight.com/careers. You can apply through the portal. Or if you're a React Day New York, audience member, feel free to reach out to me on Twitter, and we can go from there. Thank you. Okay, let's jump into Core Web Vitals. So Core Web Vitals are a set of 3 metrics, and they're not actually so much performance metrics, better really described as user experience metrics that try to answer 3 key questions. The first is, how fast does the page load? And for that, Core Web Vitals uses a metric called largest contentful paint, or LCP. How fast is the page interactive or responsive to user input? And for that, the metric is first input delay, or FID. And then finally, how visually stable is the page? And that's measured by a metric called cumulative layout shift, or CLS. And we'll talk about each of these metrics in detail in a little bit. But the key thing to note is these are really, only the first one is really about raw performance, and the last one is really one of purely user experience and doesn't really capture how fast it is. And the real reason to pay attention to these 3 metrics is they've been formalized by Google as part of the search engine ranking algorithm. So starting in 2018, Google was using speed as a ranking factor on the search results page, but they didn't tell us what they were looking at. And then in May of 2020, Google said, we're going to level the playing field, for example, whether you're AMP or not, and we'll use these 3 metrics is how we're going to actually rank pages in terms of their speed on the search results page. And they gave basically the industry a year to adopt and adjust. And then in June 2021, they actually rolled out the page experience update, which included the Core Web Vitals ranking factor. So just a few months ago. And they've reserved for themselves every year the option to change what's in the Core Web Vitals. So in some sense, what you're going to hear today has an expiration date, in that we might see next year Google retiring some of these metrics or adding new ones. We'll see what happens a year from now. And a key thing to note here is that in that time from May 2020 to June 2021, basically about 30% of the internet now passes Core Web Vitals, which means if your competition very well may not be passing Core Web Vitals, this could be a opportunity for you to actually leapfrog them in the search engine rankings. And if you're in, say, an e-commerce field or another field that highly depends on Google for a lot of its traffic, and in e-commerce, more than half of your traffic is often coming from search, this can be critically important. And the search engine result page is fixed real estate. So it's zero sum. If someone moves up, somebody else moves down. So, we've often said speed improves conversion rate. And sure enough, Google has found that if you pass Core Web Vitals, you get 24% less abandonment rate. Now it's actually impacting where you stand on the search results page. So it's actually growing your traffic, potentially growing your number of users and growing your revenue in a new dimension. And it's actually, in some sense, stealing it from maybe your competition if they were also on that search results page and you've pushed them down. So that can be really impactful in the marketplace. And over the last few months, this summer, as the page experience rolled out, people were wondering, is this going to be like SEO Armageddon? Is my SEO rank going to tank? Or is it going to not amount to anything at all? And Systrix, watched the rollout over the past few months, and it turned out to be what Google told us it was going to be. It was not more important than other ranking factors like how relevant your content was on the page. But it is clearly measurable. Here you can see in the graph on the right, the good domains pulling away from the bad domains in red over the rollout of the page experience update. So it's clearly a measurable ranking factor. And if you're in a highly competitive field, then these could be significant differences. And so their assessment was, optimizing for Core Web Vitals is worth it if you're in a commercial website. So if you're tackling optimization of Core Web Vitals, there's a couple things, though, you should know. The first is you're probably used to lab data when you look at performance. So a good example of that is Lighthouse, which I've got a screenshot here on the right. Another good example is if you're in Chrome DevTools, or my favorite, web page test. And the goal with the lab data is to simulate the loading of a page in a controlled, consistent environment. And as a result, it tries to give you as consistent a result as possible. So that performance score you see from Lighthouse will vary a little bit, but tries to be consistent from run to run on the same machine, which is great for debugging. It's great for trying different ideas to optimize your site. But the caveat is it doesn't reflect what real users experience, because real users are unlikely to match the conditions of the simulation. And so Core Web Vitals is based on what's called field data. It is collected from real users browsing your web page, and then they're anonymously aggregated and measured by Google and reported in something called the Chrome User Experience Report, sometimes abbreviated as CRUX. And there's a couple implications here that you have to be aware of. The first is, unlike, say, Lighthouse or lab data, which is a single number, the actual results of what people experience is going to be a population distribution, like you see on this graph on the right. Some of the users, had a LCP in this case of less than half a second. You see at that peak there. And then there are other users all the way out there in kind of this long tail that have experienced LCPs that were really long, sometimes maybe 4, 5, or 6 seconds. So you've got users all over the place. And so what Core Web Vitals does is, when you look at a distribution like this, is it measures where the 75th percentile is, which is another way of saying, what did 3 out of 4 users experience at least as a baseline or as an upper limit? So here in this chart, the 75th percentile is drawn right about here, which is basically around 1.3 seconds. And what we can say is that for 3 out of 4 users, they had a LCP of 1.3 seconds or better at the 75th percentile. And all the different 3 metrics of Core Web Vitals are taken at that 75th percentile. So when you look at something like Page Speed Insights, you have to realize how to read it. It is actually a jumble of lab data, then field data, then lab data. And let me just step out of the slides here and just show you with a live example. So I ran this before the talk. This is Amazon. And so here, this number at the top is actually your Lighthouse score. And that is lab data. It is not your Core Web Vitals score. And you'll see that this has actually got the warning orange on it. But if you actually look at the field data for this page, it actually passes the Core Web Vitals, even though it's in kind of the danger zone territory. And the other thing to note here is I mentioned Core Web Vitals as being 3 metrics. There's a 4th metric here. This is not a Core Web Vitals metric, at least not yet. Maybe they're hinting it's coming. But if you have a poor FCP, you probably have a poor LCP. But the only things you really want to pay attention to when you first look at your website is these 3 metrics in page speed insights. And that'll tell you how you're doing. And here you can see the actual population distributions. And here you can see the scores at the 75th percentile. There's a little button here, a checkbox for origin summary. The difference here is what you see here is just for this homepage, the index page of the site. The origin summary is for all pages on the website. And one thing you should know is because it's based on traffic, you may not have for some of your pages enough field data that Page Speed Insights is going to show you the results of your Core Web Vitals for that page, but you can sometimes get the origin summary in those cases. The other thing to note here is this message right here, over a 28-day period. These results are measured on a moving 28-day average. So one implication of that is that you will sometimes have to wait a while to see the results you do to improve your Core Web Vitals. You won't be able to measure them immediately. We'll talk about that in a little bit. And then finally, what you see here at the bottom of the page is the lab data from Lighthouse. And you'll notice the lab data here does not line up to the field data. And that has really important implications. It means that when you do this, you really want to start with your field data results. Let me show you an interesting example. So back when the COVID vaccines were rolling out, one of the online newspapers went and looked at every single US state's COVID vaccine website and evaluated them in terms of accessibility and performance. The problem is they used Lighthouse to measure how those sites were performing. And it turned out not to reflect what actual users were experiencing in terms of the speed of those websites. So here's a dramatic example. On the left, we have Arizona's COVID vaccine website. On the right, we have Alabama's. And I captured these around the same time as that article back when these vaccines were rolling out. And you'll notice, you'd think based on this that, wow, this is going to be like 4 times faster a website because the score is 4 times better. In fact, you look at the largest contentful paint, you'll see here it's 13.8, nearly 14 seconds. And the largest contentful paint here is 3.1 seconds. So a difference of a factor of about 4 here. But when you look at the field data of users browsing these 2 pages, they're almost the same. 1.3 seconds, 1.4 seconds for the actual largest contentful paint. So this is what the lab said, and this is what the actual users were experiencing. So field data and lab data very often do not line up, and sometimes dramatically. So the lesson here is that don't worry about what your lab data says unless you first look at your field data. So the first step you're going to actually want to do in your Core Web Vitals optimization journey is set up RUM. We'll talk a little bit about why you want to do that in a second. But you want to start by looking at your Core Web Vitals. Go to Page Speed Insights, look at only those 3 numbers, and focus only on the ones that it says you're failing on. Then pull out your lab tool like Lighthouse or Web Page Test and run a baseline for that metric on your machine or in your tool. And don't expect the 2 to line up, but at least it gives you a foundation where then you can generate a bunch of optimization hypotheses and test them very quickly in your lab tool and pick the most dramatic and important ones or the ones that are easiest to implement. And then once you've done that, once you've completed kind of that lab optimization phase, you don't know if you're actually going to improve the Core Web Vitals of your users. And we've had clients do this. They think they've actually improved it. They roll it out. It turns out it doesn't improve things. So you need to do is release it to your users, preferably in an A/B test. So you can remove confounding variables like maybe a certain set of traffic happened, on one day, slower traffic, or maybe you got a different set of phones, like faster phones. So ideally, you've got an A/B test to tease out whether your optimization really improved things, and then go back and look at your field data to see, are those metrics still failing or have they improved at all? The challenge here is that because of that 28-day window, you might have to wait days or weeks to really start seeing the improvement depending on how big it is. It's a little better in Google Search Console than in Page Speed Insights, but you still have to wait a while. And so for that reason, what you really want to do is you want to set up your own real user monitoring so you can get faster feedback, and you can bring this cycle into a lot faster feedback loop. The good news is you can use RUM. It's actually built into Create React App is to use the open source Web Vitals library. I highly recommend one of the first things you should do is make sure you connect that up to your console, so you can see in your console log statements what the core vitals values are of your pages as you're developing. That's really useful feedback. But then you can actually plug this into your analytics like Google Analytics, and there's actually some documentation on how to do that in Create React App that I recommend you check out. The problem is once it's in Google Analytics, it's not always the easiest to parse and to isolate still where problems lie. We do have a RUM tool that is free at Layer Zero. I encourage you to try it out. try.layerzero.co/react-day. It will give you real-time results. Here we're talking minutes instead of waiting days or weeks to know if your improvement improved things. It's really easy to install on any site, even if it's not hosted on Layer Zero. And it's got some other goodies built into it. It has some automatic A/B testing integration with our own Layer Zero A/B testing. And it's got some stuff in there that helps you isolate problematic elements in pages, especially if you're in a single page application. So the takeaway here is optimizing core vitals. You need to realize it's going to take longer and more difficult. It's not something you can put on for a day or maybe even a sprint. You need to actually roll these changes out to users. It is more like an A/B test. And that's something that you and really your boss need to be aware of. And so you're in it kind of for the long haul when you're optimizing for core vitals. Okay, let's do a lightning round on the different metrics and what some of the most impactful optimizations are. So the first one is largest contentful paint. And this is really measuring how long it takes for the largest image or block of text in the viewport to become visible to the user. And if you want to pass this metric, you have to do it in 2.5 seconds on a user's device. So here's an example of that. And what the browser is doing is, as the page is loading, it's keeping track of what is the largest piece of content on the page. And that's being illustrated here in that green highlight. And you'll notice that it can be either text or it can be an image. It can actually change over time. It starts as being just that little visual stories text at the upper left. And then it becomes the headline over here. And then even as these other things, trickle in, none of them is bigger than this until it's the hero image. And then that becomes the new largest contentful paint element. And so one thing that would have, really helped the loading time of this page is if they could have had this largest contentful paint image render here, even before the headline, if it was possible, although this is text, so that's unlikely, it would have improved the LCP of this example that you're seeing here. Another thing is, if this image was smaller, then the largest contentful paint time would have been this thing. That would have helped optimize the speed of this page. One key thing to know if you've got a React single page application, though, is that Core Vitals is not really rewarding the real speed of your page. So if you're in a multi-page website, let's take this one on the left. Let's imagine the first load was about 4 seconds, and then all the subsequent pages might have been 3 seconds on that same site because some elements were cached. And then you go for maybe the user goes for about 5 pages. The average page speed there is about 3.1 seconds. But in a single page application, let's suppose that page was 3.5 seconds to load to begin with, and then it's a single page app. So all those browsing pages are really quick transitions, so you don't have to reload the page. The actual speed that the user has experienced is about like 1.4 seconds, better than 1.5 seconds. Unfortunately, Google's Chrome can't tell those single page transitions. They just look like regular JavaScript running on the page. They don't know those are real pages. And so Core Vitals in this case would have thought this page loads in 3.5 seconds on average. That's the LCP for this page. So the Chrome team is aware of this and they're working on fixing it. They're doing a lot of research on this. Maybe by 2022, they'll have fixed it. But in the meantime, know that Core Vitals is underestimating the speed of your React single page application. That doesn't mean you shouldn't invest in a single page application. Just know that if you're comparing yourself against a multi-page site, there may be discrepancies and differences. Okay, when you're optimizing your LCP, kind of as I teased about earlier, the key thing you want to do is identify that big LCP element and then deprioritize almost everything else that prevents it from rendering. So let's briefly take a look at how to identify the LCP element. You can see this in Google Lighthouse. There's a largest contentful paint element report. You'll see later on in the page, it'll tell you what that item is. I'll just show you in DevTools. Actually, I'll just clear this out. First thing you want to do when you run Chrome DevTools and you're running the performance tab is just set it to about blank. Then you hit record, and it seems like we're using Amazon today. And hit stop. There we go. And then you go down to timings right here, and you can see there's LCP. It'll tell you when the LCP happened for this page. You can see right there in the frame where the image came in. And you can actually go over this and it'll highlight. You notice when I hover the related node, it tells me the time the LCP element came in. And I can actually even click on this and I can see it in my elements pane. So what you want to do is once you know what that largest contentful paint element is, you want to make sure you deprioritize everything else that's preventing it from rendering. So that could be a font. Maybe you want to inline it, or maybe you want to remove that font. It could be CSS. CSS, that could be for stuff later down on the page after that element. So take the CSS that's, shall we say, critical. It's often referred to as critical CSS, and make sure that CSS is earlier on the page before the element so that it can render as soon as possible. And then finally, it could be JavaScript on the page. And you want to make sure that that JavaScript loads later if it's not needed for rendering the page. Which brings us to probably one of the most impactful things to improve your LCP, which is to use server-side rendering. So in, say, client-side rendering, which is what you'll get out of Create React App, the browser isn't going to show any HTML, including the HTML for the largest contentful paint element, whether it's text or an image, until that JavaScript is parsed and run and executed, and it builds out all the HTML on the page. That can take a while, especially on a slower phone. So with server-side rendering, we let the server generate the HTML, and so the browser can start rendering that HTML. It can even see images and other resources and start fetching them in advance so that the page can render as fast as possible without having for that JavaScript to download, get parsed, and execute before it can show stuff. And then later on, that JavaScript does run in a process called hydration. We'll talk about the consequences of that in a little bit. So number one recommendation here, use server-side rendering. You want to use something like Next.js or say Gatsby, or you can wire it together yourself, although it can be really painful to add in server-side rendering after the fact or build it yourself. Highly recommend using a framework that does it for you. The challenge with SSR is you need to do it properly. You're now waiting for the server to generate the server-side rendered version of that page, which actually might cause more delay than you might be saving. So the solution here is you need to do SSR properly, which means you need to really stick a CDN in front of your SSR rendering tier, whether that's a node server or whether that's serverless. Put a CDN in there and then cache those pages so that they're returned as fast as possible. And one consequence of this is you might have to do some re-architecting of your page to make sure it's cacheable. You might have things in there that are user specific, like the user's logged in state, or in this case, the item cart count, or product recommendations that are user specific. So you need to remove those from the SSR rendering of the page and then have those late load client side after the page is rendered, so that doesn't affect it. And hopefully none of those elements that you're late loading happen to be the largest contentful paint element. The other key thing you want to do is make sure you normalize your cache key. So here, for example, is a user browsing from Instagram to the mobile page of, say, Sephora. And if you actually looked under the hood, what's happening here is they're clicking on a link that's really, really long. It's got a lot of parameters on it. In fact, Instagram will sometimes add a per user field to it. And a regular CDN will very often see this as a unique per user page. So it's basically getting rid of that CDN that you decided to set up and making it useless, even though you're actually sending a bunch of users all to the same content. It turns out the only thing that affects the content of this page is really the SKU ID. The rest are just marketing data that JavaScript on the page is going to use. So in this case, you want to tell your CDN, hey, ignore everything but the SKU ID parameter when you cache this page. In Layer 0, we do have something that makes this really easy called Edge.js that you can take a look at if you want. Very often, the largest contentful paint element is an image. So you want to make sure you optimize the size and format of your images. And the next image component, if you're using Next.js, will help you do this. Another key thing to note here is if Chrome supports a new image format and Safari does not, Core Web Vitals is only measured on Chrome devices. So you are incentivized to adopt whatever the latest image formats are, simply to boost your search engine ranking. Another thing you can do with your images is make sure if they're hosted on a separate domain or a subdomain that you use a pre-connect or preload that lets the browser start initiating the request for that image earlier, so that it can fetch it and display it faster. Another thing that can compete with your LCP element is requests for other images on the page, especially if you've got like a category page where a lot of those images are competing for the bandwidth. So what you want to do is actually lazy load the non-LCP element images, especially the ones that are below the fold, so that only the ones above the fold can render and are getting data as quickly as possible. And that can accelerate the LCP image. A technique that sometimes works, but not always, is inlining images as base 64. We've had customers try it. It works sometimes in testing tools, but sometimes not worth it when you actually look at the real world results in RUM and Core Web Vitals. So be aware that not everything works. Let's talk about first input delay. So first input delay measures the time from when a user taps on a page to when the browser is able to respond to that. And that's a time, they measure that time. If you want to pass this, you want to be at 100 milliseconds for the 75th percentile. I want to note, the first input delay does not actually measure how quickly you draw to the screen, just that you're able to respond. So here's a diagram from web.dev. And the browser is basically doing, it's looking between two time periods. One is called FCP, the first contentful paint, and then TTI is the time to interactive, which personally I think is not the best metric, but we can talk about in the Q&A if you're interested. And here it's actually visualizing the main thread. And you can imagine these brown areas, these light brown, are when the main thread is busy running some other JavaScript you've given it. If a user taps on a page while you're running JavaScript, the main thread is single threaded. It's only one thread. So if the user taps on it, then the user's response isn't able to be responded to until this task is done. And that delay from when the user taps to when the browser can respond is measured as the first input delay. Now note, if the user tapped here, the first input delay would be 0. But if they tap here, this could be 100, 200, maybe even a second if it's a really long task. So when you're in a lab situation, unfortunately, you don't always have a user tapping on it. In Chrome DevTools, you might. But if you're in Lighthouse, you don't. So very often we use a metric called total blocking time. And what total blocking time does is it takes these JavaScript execution periods and it basically subtracts 50 milliseconds from them. So if you've got less than a 50 millisecond long task, it basically ignores it. And then it gives you a 50 millisecond grace period and then adds up the sum of all of these long tasks during that FCP to TTI. And then it gives you a total amount of time your main thread was blocked. I want to warn you, though, that total blocking time isn't always representative of FID. And I wouldn't really focus on total blocking time, again, unless your core vitals show that you got a problematic FID. The number one thing, a lot of our customers have found that's really useful is lazy hydration. So I mentioned earlier that when you're using SSR, we render the page very quickly, but then later on, JavaScript has to run to make it interactive. Fortunately, you've now given the user a page that may look interactive, and they may be encouraged to touch things while you're actually busy running JavaScript to connect and make it interactive. And so that can actually slow you down and cause poor FID. So the solution here is to only hydrate those components above the fold, or maybe not hydrate or lazy load components below the fold when they become visible or later on during the process. There isn't really a canonical way to do this, but you can find a lot of blog posts and tutorials and some modules for it. We actually built this into React Storefront. There's a LazyHydrate component. It's open source. You can go see how it's implemented. Basically, you wrap some expensive to render component inside a LazyHydrate component, and you give it a prop with whichever algorithm you want to use to hydrate. In this case, when it becomes visible. Some other quick FID optimizations. Very often, the JavaScript you've written yourself might actually find its third-party marketing scripts that have been added, often through a tag manager, that are causing excess FID. So Lighthouse has a great third-party script report that's helpful in identifying candidates you might want to delay or defer, and you might want to delay them till after TTI if you can. The other thing is sending less JavaScript is going to probably be less JavaScript to execute. So these are where your classic techniques that have always been good practices, code splitting, tree shaking, and dynamic imports would be really helpful. Some of this is actually done for you in Next.js. So again, recommend using something like that. Okay, let's talk last about cumulative layout shift. The definition of cumulative layout shift is really kind of complicated. It's also unitless. You can kind of think of like 0.1, which is the 75th percentile threshold, is like 10% of the page shifts. But the goal here is to measure unexpected changes in page layout. So imagine you're browsing a page like this, and this ad just kind of pops up in the page, even though you haven't touched the page at all. And maybe this happened during loading. That's an element causing an unexpected shift you didn't ask for in the page. And you can kind of think of layout CLS as measuring the percentage of page shifts that happen as a percentage of the screen real estate. The most frequent causes of poor CLS are actually images that don't have dimensions. So make sure you've got the height and width set on your images. The other typical cause of poor CLS is dynamically injected content. There's a couple solutions here. The first is only show this content when you know you can render it onto the screen or get it less than half a second, 500 milliseconds. You're given a 500 millisecond grace period when the user taps on the screen to render content like that, and it won't be counted towards your CLS. The other thing you can do is you can have a placeholder or a skeleton content until you get the real content loading, but make sure you've got as close to the right proper height and width for that content. And then the other thing you can do is you can render that content off screen and then move it onto the screen. So let me show you an example of that right here. So here I've got a page, and it's actually got two footers. I'll show it. This is a simple Next app with some lorem ipsum text, and you'll see there's a site footer here. And as I navigate this page, there's some debugging information here that'll tell me when I've incorporated CLS. And what's happening is, as I'm moving this page between these pages, this site footer is moving up and down, even though the text is changing. And so CLS is registering this as a layout shift. So if you have this, which is not the most elegant example, at least animation, now, and this was built by one of my colleagues, you can see that as I'm navigating, if I've put it off the page, and you probably want a little better render animation here, you can see that I'm no longer accumulating any CLS. Another interesting thing here in this example is I showed you that we've got this site footer. The way this is architected in the code is inside the app component is where we're sticking the footer. There's another part of this demo where I can hide the site footer, and I can put the footer as a child component of each page. So each page 1, page 2 now has a simple footer element, but it's now a child of the page instead of the parent app. And when you do this, what you'll actually find is that it actually isn't accumulating any CLS, because now, according to the CLS algorithm, it looks like a new element, even though to the user, it looks the same. So sometimes you can do things like that to avoid accumulating CLS. And then lastly, let me just show you how you can identify CLS. So I'm going to go here and hit record, and then go back and forth between this page and this page. Let's just do it again. And you'll see here in the timings and experience right here underneath timings. If we zoom in on that, there we go. You can see there's a layout shift that identifies, and it'll actually, you can see as I highlight it, it'll hover over and tell me which element was a layout shift element. And it'll even tell me how much layout shift it caused. Okay. So that's been a whirlwind tour of Core Web Vitals. If you want to dive in a lot more detail, I recommend starting at web.dev. That's Google's official source for all things Core Web Vitals and web development. I also recommend one other resource if you want to go really deep, and after you've kind of gone through everything on web.dev, is the Smashing Mag annual performance checklist. It's a lot to go through at once. I did it once many years ago. But if you've got a problem, go look through there for the problem you're trying to solve, and you'll probably find a useful, helpful idea or pointer. And then finally, I said the first step of the journey on optimizing Core Web Vitals is installing RUM. So again, recommend or you try out Layer 0 RUM. You can go to try.layer0.co/react-day and install on your site and begin your journey on optimizing Core Web Vitals. Okay, thank you. I think now we'll do Q&A.
Hi, Ishan. We do have a question. I have posted it on our chat. If you can see it. Yeah. Perfect.
Yeah. So in many companies, the marketing teams enjoy using tools to measure Core Web Vitals with their own favorite service. Typically, third-party JavaScript can actually hurt Core Web Vitals by measuring it. Thoughts on how to address this? For example, the lab data shows poor performance because you're measuring with third-party JavaScript. So it is true that, especially, and it's right that other teams in the organization can be like a kid in a candy store with tag managers and add a bunch of things. What I will say is that measurement of Core Web Vitals in RUM turns out to be relatively lightweight, and that's because the way Core Web Vitals measurement works, the browser has a native API, and all you're doing is collecting the Core Web Vitals data as it happens. And so what you want to make sure is that the service you're using is doing this as lightweight and as efficient as possible. So you actually don't have to try and capture, say, for example, the LCP as quickly as possible. The browser will remember it, and then you can ask for it later. So what you want to make sure is you've got a RUM tool that is not going to be hurting the JavaScript of the Core Web Vitals of your page when you add it. And you kind of hinted at the answer here, which is, before you add the RUM measurement tool, set it in a lab tool and look at the Core Web Vitals of the site on one of the lab metrics, and then add the JavaScript and look at it after and check your TBT, check your other things. If, for example, it's interfering with the LCP, very easy. Just move that JavaScript later. You don't need to grab your Core Web Vitals as immediately. You can delay, for example, the analytics that are grabbing your Core Web Vitals. If it's FID, you might have to optimize it a little bit. It's unlikely to impact your CLS. So in practice, we actually don't, regardless of which tool you use, unless you've actually home rolled using that Core Web Vitals that's built into Create React app, we usually don't see people who actually have that issue, but it can happen, and that's the right way to deal with it. Our Core Web Vitals measure in Matomo. I am not familiar with what Matomo is. I'll have to. Matomo is it's a free open source web analytics application. Yeah, so I'm not as familiar with it. I'll tell you, most of our customers actually use things like Google Analytics or Omniture. I'm not familiar with Matomo. If Matomo lets you send custom data to it, like custom fields or custom metrics is what it's often called in Google Analytics, then I'm guessing you can probably measure it in Core Web Vitals. You just will have to do the work yourself to wire it up and connect those metrics into that analytics package. And then the hard part is actually making sure, and I've dealt with this in a couple different analytics packages, is getting a distribution out of the appropriate distribution out of the tool. So you might be, dumping the Core Web Vital data, say the LCP of all your users into this tool. But then what you want to turn around and say is, give me the 75th percentile. And very often tools will give you like the average or the max and the min, but they weren't built for Core Web Vitals. And they won't give you even that graph, which is really helpful when you're trying to figure out how bad is the problem. And that'll be the real challenge. And so the real question when you're looking at an analytics tool is, A, can I get custom data into it? but B, what is the format of the reporting that I want to get out of it? And will it match how I need that data to be analyzed for Core Web Vitals? Is the other part of the equation that isn't as often asked.
Right. I think this pretty much covers it.
Okay.
Ishan. Thank you very much for all the information. From what I see in the comments, a few people will need to watch it again and get as much as they can in.
It was a crash course, so there was a lot to get in there.
Yeah, for sure. So that's why we also have it available on YouTube, so people can rewatch it, and in case they missed something or they want to revisit something. So yeah, guys, feel free to reach out to Ishan for any question regarding the matter. I think you've shared your social URLs and how people can get in contact with you.
IANAND on Twitter.
Quite simple.
Yeah, quite simple, that's my first initial and then my last name.
Yeah.
And my DMs are open if you want to ask a question that way as well.
Perfect. So thank you very much for the talk. Appreciating taking the time to get all of this information together and for all the insights for the Core Web Vitals. For the rest of you guys, we'll see each other quite soon. Actually, it's time for the next topic. And from everyone, I want to say thanks, Ishan, for getting us all together. And yeah, have a great day.
Thank you for having me. And I hope everyone has a great rest of the conference.
Yeah, thank you very much.